Hello, welcome to a new series in which we'll be learning geometry nodes by making games. This is not the way games are made, but we'll be just doing it to explore geometry nodes. In this video, I will build a sliding puzzle game. Can I win this game? Well, let's find out at the end of this video. I'll start with a curve object because when we go in edit mode, we have access to the draw tool, which allows us to create curves by just drawing. Let's get into geometry nodes. Create a new node group. I will name it to puzzle game. First, I want to delete all the curve splines and leave only the last one. So, how to get the last spline? Add a delete geometry node, set it to delete splines. Add a domain size node, set it to curve, and we get the spline count. If we subtract 1 from it, we get the last index. Why are we subtracting 1? Well, it's because counting starts from 1, while indexing starts from 0. If the index is not equal to the last index, delete that spline. That's all we need to do to get the last spline. Now I want to make this spline 2D, meaning it will be flat to the ground. So, how to get a 2D spline? Add a sample curve node, set the count to 2, because I will only be needing 2 points in this case. Add a set position node, move the points to 0 location in the z-axis by separating the position and only combining the x and y axis. Then connect it to the position of a set position node. That's all we need to do to make the spline 2D. Now, I want to get one of the 4 direction vectors presented by this geometry. How to get a direction vector? First, I will move the whole geometry so that its first point is at 0 xyz location. Sample the position of a point with an index equal to 0, scale it by -1, and use a set position node to offset the geometry. Now I want to move the second point so that the distance is equal to 1. Let's do it by connecting a normalized position to the set position node position socket. Add a mesh circle, set it to have 4 vertices, and the radius should be set to 1 meter. I want to use this as a reference for the exact perpendicular direction. So I will sample the position of a point nearest to the second point of the curve. Take note, if you connect an index node to the selection, it means we have selected all other indices except index 0. And lastly, let's sample the position of a point with an index equal to 1, which is the second point. And that's all we need to get the direction from a curve. There might be other simpler ways. This is not the only way. Now let's make the points we will be moving. We will make a grid of points and we will instance planes on them. How to draw the game? Add 2 meshline primitives, put them in a group. Connect the counts to the group input new socket. These values will be the resolution of the game. Connect each socket to a combine XYZ node and then take X from one combine XYZ node and Y from another, connecting them to the group input. Instance the X-axis mesh line on the Y-axis mesh line. Now I want to centralize the whole mesh. So realize the instances. Connect a bounding box to the geometry. Take the max and scale it by -0.5 and use the offset on the set position node. We will also be needing a vector having x and y offset. So combine x and y using another combine xyz and then output it to the group output. Let's make the plane we'll be instancing on the points. Add a grid, connect the x and y offset to it. We can subtract a spacing value from both x and y in case we want spaces between the points. Now let's get to moving the points when we draw the spline. We will be doing this in a simulation zone. Then after the simulation zone, we will instance the plane we made on the points. How to move the points in a simulation zone? Multiply the direction and the offset and then connect it to the offset of a set position node in the simulation zone. Now if I hit space to play and draw a spline in edit mode, we see that all the points move together continuously. How can we use the offset only once in a simulation zone? Connect it to the true socket on the switch node. Let's create an attribute, maybe name it move, equate the value to the spline count, and connect the value to the switch node. This will be false because we have not assigned any value to the attribute. We then store the attribute after we have used the offset with the set position node. We are storing the same spline count so that when we compare again, it becomes true and we'll be using the void offset. And that's all we need to do to use the offset once. Now we need a gap which we will be using to move other points. So add a delete geometry node at the end of the simulation zone. We are going to delete a point with an index equal to the number specified here. This can be any number representing an index available. The gap will be moving to the opposite direction of the offset, so scale it by -1. Use another set position node with the selection connected to the index of the gap. To know which point will be moving, let's sample the position of the point we are deleting to form a gap and add an inverted offset to it. We will equate the position of each point to this position, then connect it to the selection of the set position node. Now if we hit space to play and draw a spline, we are able to move the points and exchange the location. But we still have another problem. We can move the gap point out of the grid. So, how to know when to move or not? Connect a domain size node to the geometry coming from the first set position node. Also merge the vertices. So if we are moving to the location where there is already another point, points are merged. But if there is nothing, no points are merged. Add a comparing node set to not equal and compare the counts from both domain size nodes. And connect the boolean to the switch node, which is bypassing the second position node. If we check the problem, it will be fixed. How to instance different numbers on points. I have found the product of the resolution and use it as the iteration of the repeat zone. Inside the repeat zone, I am continuously adding 1 in each iteration, and we are converting the value to a string, which is converted to a curve and is filled and then made to an instance. Join the instances to the previous created instances. These instances are picked separate when they are instanced on the points, while the pick instance is ticked. I added a lot to this node group, but I will not explain everything. If you have any questions and need explanations, you can join the Discord server. The link is in the description. I'll leave a link in the description of this node group I'm about to test. To play, I just add the node group and add the levels node. Pick a level and connect it to the saved game. You can tick show go to know how you are going to rearrange the planes. You can create these levels by adding a back node connected to the save game output socket and create your own challenge by setting the resolution, hit play, and then randomize the numbers. Connect the back node, back